All right, now let's look at some example problems using some of the information we've learned. So this problem asked us to determine if line AB is tangent to the circle. So line AB is right there. And here's how we would use what information we know. If this line is tangent to the circle, here we have a radius that meets at the point of tangency. So if this is a tangent, these will meet at a right angle. And if they meet at a right angle, that means this triangle is a right triangle, and the Pythagorean theorem should hold true. That's one good way to test for right triangles. If the Pythagorean theorem holds true, then you have yourself a right triangle. If it comes out to be not true, then you're not going to have a right triangle. So let's test out the Pythagorean theorem on this. A squared plus b squared equals c squared. So let's start with A. I'll use this side for A because that's nice and simple. So I'll say 2 squared plus, and I'll use this side for B, but notice they don't give us the whole length. Turns out if we're clever, we can work around this. We know the radius is 2. The diameter is always twice the radius, so the length of this segment here should be 4. So the length of B would be 4, and C has a length of 5. So if that statement comes out to be true, then that line is indeed tangent. So here I would get 4 plus 16 equals 25, and we can see that 20 does not, in fact, equal 25. So AB is not tangent to the circle. And again, if it was tangent, this would have come out to be a true statement. However, it did not, so it is not tangent. Alright, this one is, in my own mind anyway, fairly fun. I kind of enjoy problems like this. Find the perimeter of the polygon. So that would mean this triangle here, and what I'm trying to find is the distance along the outside of that. So I need to add up all these sides that are around the edge. And so what I need to do is use the fact that if I have tangent lines, and we can see that we have a bunch of tangent lines here, the distance between the points where the tangent lines cross and where they or the point of tangency is going to be congruent. So I can look at this and I can say that's congruent to that, that is congruent to that, and this one is congruent to this one. So now the job is to figure out exactly what all those distances are. So let's start with this distance right here. I know that the entire distance is 18.3, and I know that this distance is 11, so the question becomes, what do I add to 11 to get 18.3? And that must be 7.3. So if I know that that is 7.3, this must be 7.3 as well. Now I can take this information. Let's try and find that. Well, I don't know anything there. I know this is congruent to it, but I don't know anything about that either. I know this distance, but notice this. I know that this is 11, and this is congruent to it, so that right there must be 11 as well. And if this is 11, in order to find this, I would take 20.9 minus 11, and that is going to be 9.9. And if that one is 9.9 right there, this one must be 9.9 as well. So I had to use the fact that these are congruent and do some subtraction to find missing pieces until I found all the pieces around here. Now to find the perimeter, all I have to do is add up all those side lengths. Now, one place to be very careful here is that when you add these up, make sure you don't double count anything. So I'm going to start at this point and work my way around the polygon this way. I have a short side of 9.9 plus 7.3, And now I've got this whole distance for the long side, so I might as well use it, plus 18.3, plus, and again I have that whole side there. And now all I have to do is add those up. And since it is early and there was no coffee this morning in the cafeteria, how dare that happen? I'll add those up on a calculator and we get 56.4, and that would be our perimeter. We're not given any units, so we can't say anything further than that. But again, we're using the fact that these are tangent lines, and thus these must be congruent to calculate the perimeter. Alright, now we're asked to solve for x, assuming that lines which appear to be tangent are in fact tangent. And so what we need to do on this one is realize that since I have two tangent lines that meet at a common external point, that this segment is going to be congruent to this segment, which means I can take these two measurements and set them equal to each other, because if they're congruent, they are in fact equal. And now that I have this, all I need to do is solve it. Let's get all our variables on the same side. So I'm going to subtract x from both sides, and I'll get 5 equals x plus 5. And if you're clever, you may already know what's happening. So let's go ahead and subtract 5 from both sides. And we see that x must in fact be 0.